Hi, my name is Stephanie Wong, and this is my project 2 for Physics 111. So, the everyday activity I chose to show energies that are transforming is making coffee. And so, the first step is to grab a mug from the shelf. And so, these mugs are on the shelf and they're way above the y=0 line. So, therefore, they have super high potential energy. And in order to grab a mug from the shelf, I need to utilize the chemical energy that's in my body from like what I ate for dinner or, just fat that's stored in my body. I need to utilize that chemical energy and turn it into kinetic energy. And so I grab the mug, that's kinetic energy. And now, since it's at this y=0 point, now it has a low potential energy. Now the second step is to grind the coffee beans in an electric grinder. So here are my coffee beans, my electric grinder, and here's my final product. So I use the electrical energy from the battery in this electric grinder, and then I turn that electrical energy into kinetic energy. This is from the blade spinning, and also comes from friction from these beans are in here, right? And they're being like swirled and swirled and spun and broken apart. And so this friction, it is kinetic energy. And now we have broken coffee beans. And this kinetic energy is sort of turning into thermal energy. These coffee beans, since they've been broken up and because of the friction, they're a very tiny bit warm, which means that it's turned a little bit into thermal energy. So the next step is to set up the French coffee press with coffee beans. So this is my coffee press, and these are the coffee beans. And I use chemical energy from my body, just like grabbing the mug, from my food previously eaten and the fat in my body, and I turn that chemical energy into kinetic energy by grabbing the press, putting it on the table. Then also, getting the coffee beans and then putting them into the coffee press. So next, I boil a kettle of water, and this is where a lot of energy transformations happen. So you can see the stovetop here, the kettle here, the little electrical source, and this is sort of like a blown up view of the kettle over here. So I get the electrical energy. This is from the wall outlet over here. And I turn that electrical energy into thermal energy, into heat from these electrical burners. And this heat goes into the metal kettle. And so now this thermal energy is going to be turning into kinetic energy. Move this down. And kinetic energy is, motion. And so this heat here it's exciting these water molecules. And it's speeding them up more and more and more. And it makes the water hotter and hotter. And over time, with a ton of this kinetic energy, it actually breaks the bonds between the molecules and we get steam. So you can see here that this is the liquid of the water, and then now it's turned into steam. And I'm not sure if this is correct, but I think that now this kinetic energy actually turns a little bit into sound waves. And this is because the steam has a lot of kinetic energy. It's moving around everywhere. And now it's flowing out through the narrow opening of this kettle. It's flowing out this way. And when it's flowing out, then it's creating a shrill and a really high-pitched whistle. So my little laser pointer just died, so we'll just have to read it all. Okay, so now for the next step, you need to grab the kettle and pour water into the coffee press. So first you need to put the lid on the press and press down on the plunger so that the coffee grounds are at the bottom of the press. And this is you lift up this kettle and you get this all ready with chemical energy from your body, and you turn it into kinetic energy, grabbing the kettle, pushing the plunger down, and then also pouring coffee into a mug. And now look, now you have your little delicious cup of coffee. So next we're going to go into, I wanted to focus a little bit on the system that I chose. So the system I chose was water in the kettle. And then the energy that was put in is electrical energy. This is from the burner. And thermal energy. This is the heat that was, produced from the electricity. And so these energies are going into the system. And we want this water to get hotter so that we can make coffee. And so we want to make kinetic energy and we want to make thermal energy. And really, in like a perfect world, all this energy would go straight into the system and just stay inside the system. But it doesn't really happen that way. There is some thermal energy, and I'm sure some other things that get out of the system. But examples of thermal energy that I thought could get out were probably heat that is on the surrounding metal in the kettle. The energy doesn't just go straight into the water. It heats up the kettle, and then that actually heats up the entire device of the kettle, which isn't really that efficient. And then we have the steam pushing out of the whistle. By doing that, we're losing some of the water, we're losing some of the, kinetic energy, we're losing some of the thermal energy too. And so, I had my whole example on an electrical stovetop, and I researched and I wanted to see, okay, so what's really the most efficient way to boil water though? And according to howtomonk.com, it says that a 1 kilowatt hour water heater is super, super efficient. And you can see this because the electrical stovetop takes like 150 seconds to boil 1 cup of water, whereas the 1 kilowatt hour water heater takes 90 seconds to boil 1 cup of water. And so then the question I thought of myself, I was like, okay, so how many watts does a 1 kilowatt per hour water heater produce compared to an electric burner? So how much, the 1 kilowatt per hour water heater must have a lot more energy because it's not being wasted on the environment or anything else. It's just staying in the system. And so to do this, first, watts is joules divided by seconds. And we're going to say that the initial temperature is 15 degrees Celsius. So first we need to define the joules to heat 1 cup of water, in order to figure out the watts. So I decided that the temperature was going to be 15 degrees Celsius, and the final temperature is 100 degrees Celsius because that's boiling water. And then 1 cup of water equals 236 grams, and then the specific heat, which is how much heat it takes to raise 1 gram of water to 1 degree Celsius. The specific heat of water is 4.18 joules. And this is diving a little bit into chemistry, but it still is talking about the energies and which one would be, which device is more efficient and how much more efficient it is than the other one. So the equation I'm using is joules equals the specific heat times the mass times the change in temperature. And so I input all those numbers, and I got 361,800 joules. As that's how many joules it takes in order to boil 1 cup of water. And then so I was like, okay, so now I need to transfer all these joules into watts. So I transferred the joules into watts with the kilowatt per hour water heater and then also with the electric burner. And you can see the difference in power. So the kilowatt per hour has 4,012 watts, whereas the electric burner only produces 2,407 watts. So the kilowatt per hour water heater is twice as strong as the electric burner. And I did the percentage and I found that the kilowatt per hour water heater is about 60% more times efficient if you want to, if you want to boil your water faster. And so this is the end of my project. I really enjoyed it and I learned a lot, and it was really fun thinking about the different energies that go into making coffee, and it was fun putting in my own numbers and trying to figure some stuff out. So